record. All right, now we're recording. Looks good. So, going over here, everyone can see this Word document?
Yes.
All right, so question one for the homework was basically the following is about getting confidence interval for the congressional feeling thermometer, which is congress.therm in the NES data set. Part A was report the R code that gives you a 95% confidence interval for the congressional feeling thermometer. And you want simply just the code. So that was this t.test is the function, and then we're doing it under Congress therm. So let me go over here. So what we have right here for question one, the variable that we're using is the congress.therm. Everyone can see my R open, right?
Yes.
Okay.
Yes.
So let me just run these real quick, get the data loaded. So when we run this t-test congress.therm, that is where it gives us this, and it gives, you know, your T, your DF, your P value, which the P value is that super small number. So that means that we are able to reject the null hypothesis. And so the 95% confidence interval, which is what this question is asking, is the 53.90658 or 255.755. So here it says report, part B is report the actual confidence interval, write in a sentence stating what the confidence interval is telling us. I have a typo. Then that's when we write, this is where he really wants this specific sentence. We are 95% confident that the true mean of Congress feeling thermometer lies in between 53.9 and 55.8.
Okay. Have that.
Yeah. So like I said, super simple.
Yep.
I mean, if you wanted to, you could like rewrite the sentence a little bit to where, you know, that the true mean of how people feel towards Congress lie between, you know, but I'm pretty sure that's exactly the way that he did it in class with just that. So that's what I'm leaving is just the true mean of Congress feeling thermometer lies in between 53.9 and 55.8. So this next one, part two, was the one that took a little bit more time. And so this is the question that is being asked is, are Democrats more favorable towards Congress than Republicans? We're supposed to do a hypothesis test at the 95% interval, and then it tells us the relevant variables are congress.therm and also party ID. So when we come over here, this is the one where we need to make our subsets for Democrats and Republicans. So basically splitting apart the party ID, like by the party ID variable. And so one thing that you can do, this will go away. Yeah. Stupid Zoom controls are getting in the way. So if you hit run on a variable, it will kind of give you what all the different things are. And so we're just looking at Democrats and Republicans, but inside party ID, there are Democrats, Republicans, and independents. Now, the only reason why you might need to open this up is, so if you're creating this subset, remember, like when you're doing these things in R, you have to have them written exactly how they are. So that means capital letters need to be the same, spaces, non-spaces, slashes, all that sort of stuff has to be identical. So when we're trying to create the subset for Democrats, you know, it's very important that we know in here that it's capital DEM. That's how it's capital D lowercase em. That is how we're finding the Democrats. And so, and then same thing for Republicans, capital R lowercase EP. And then, so you just that way, this is by looking at the data, you know exactly what, how the data is labeled so that you can do it correctly. But so we have our Democrat subset by, you know, telling it we're looking in the NES, we're looking at party ID and equals Dem. And then same thing for Republicans. So then we're going to do the t-test. So this is where, you know, as far as reporting to your code, your entire code is creating the Democrat subset, creating the Republican subset, and then you're doing your t-test of Democrats in Congress term versus Republicans and Congress term. And so when you look at the data, you know, it's going to come up as a Welch 2-sample t-test. It gives you your p-value, which is, you know, super small, it's less than 0.05. So we're able to reject the null hypothesis. And then it gives you your 95% confidence intervals, which aren't super important for this question. But then it gives us the mean of X, which is the mean of Democrats, and the mean of Y, which is the mean of Republicans. So the big thing that it was important in this, and it even said in the directions, make sure to explain whether or not you are rejecting the null hypothesis. So the answer is, since the p-value is less than 0.05, we can reject the null hypothesis that the mean of Congress feeling thermometer for Democrats is equal to the mean of Congress feeling thermometer for Republicans. So, and you can, so because that's what it's checking is, if you look right here, the alternative hypothesis, this is your null hypothesis, is that the null hypothesis is the true difference in means is not equal to 0. Or sorry, that's your testing hypothesis. So the null hypothesis would mean that the difference in the means is equal to 0, meaning that there is no difference between Democrats and Republicans on the Congress.therm. Is there any questions about that right now?
Do we have to add that additionally part 2, or you just wanted to go be a superstar?
No, that it does need to be on there. I'll get to that part next.
Okay.
So I just want to make sure, is everyone pretty clear on the null hypothesis and rejecting it?
Yes, because it's less than 0.05.
Yes.
Okay. So, and this is the one thing, like, and is like, as far as the lab notes go and what he did in class, he stopped right at this part right here. But if you see, the actual question that we're supposed to answer is, are Democrats more favorable towards Congress than Republicans? All we answered right there is saying that because the p-value is less than 0.05, we know that Democrats and Republicans means are different. So that's why you have to add this additionally, the mean of Democrats, which is this number right here, the mean of X, because Democrats are put first, that they are X, the mean of X is approximately 16.5 points higher than the mean of Y, which I gotta, one second, let me double check that because those numbers don't, I might have messed up on my math there. Or I might have copy and pasted the wrong thing. Yeah, so I think it was supposed to be 13.5. But so Yeah, so this is the mean of how Democrats feel about Congress. The mean or average is 60% or 60 points. Is they felt pretty good. Republicans, on the other hand, were 13 and a half points lower at 47. So by judging by those means, additionally, the means of Democrats on the Congress feeling thermometer was approximately 13.5 points higher than that of Republicans, meaning that Democrats are more favorable of Congress. So that is that's us actually answering the question of who is more favorable for Congress.
Okay.
And I did actually email Dr. Menchaca about this to make sure that that was supposed to be in there. And he said, yes, what you have written down is what you're supposed to have.
Yeah, I noticed that too, that we kind of skipped over answering that question in class.
Yeah. So, and that is homework 3.
Awesome.
And this part can probably be left out because it's just the data. I just put it in there anyways. I don't think it's going to give me points off for it, but this is the part that you need. All right. Yep. See, super quick. Only took 10 minutes to go through that.
Awesome. How long did it take you to do the quiz?
I'd probably say that I spent about an hour on it, just making sure I fully understood the math. And typing everything up, like, so. And I don't know why I thought that we were going to be using R in the quiz, so I basically like typed everything for the quiz out in R. So can you guys read that green okay?
Hold on, I'm trying to open up Blackboard so we can do the quiz really quick.
Yeah. Can everyone else read this okay? Because if not, like, we don't actually need R, so I can copy and paste it into Word and turn it to black, so it's easier to read.
I can read it.
Okay.
Let me see if I can read. Okay, yeah, I see. Is that all for the quiz?
Yes.
Damn. Okay.
Well, and it's a lot of redundant things and extra information. So, but yeah, like I said, this goes completely step by step. So let me know when everyone has their quiz open.
I'm gonna
Just when everyone's good to go, and then I'll start going over it.
All right, 1 second. Courses.
Do you think he'll get mad if we take it all at the same time?
No,
Okay.
I don't think so.
he'll just be like, they were really smart and all decided to do it before Sunday. Ugh. Okay, so I'm gonna open begin. And let's see. Okay, so
There's-
hopefully the first question is the same one that we're all gonna have, because I had a teacher who had quizzes like last semester when it was online, and every time that you would take a test, it would be different questions and different, like, no matter who took it, it'd just be different.
Right.
So hopefully
Yeah,
we're
no,
all
I'm
on the same
pretty
page.
sure this is the same for everyone.
Is
Okay.
it just 4 questions?
Yep, just 4.
Okay, it's question 1. Suppose that you took a survey.
Yep.
Awesome. Okay, we're good. Oh,
Is everyone ready to go?
Yes.
Yes.
All right. All right. So question 1, suppose that you took a survey of 2,500 voting age adults. One of these questions was a feeling thermometer for President Biden. Also suppose that you know that the true standard deviation is equal to 15. what is the standard error of Biden's feeling thermometer? And the answers are A is 0.3, B is 5, C is 15, and D is 0.006. So
Okay, so in my quiz, it's all different, the answers, but the answer is 0.3.
yes.
Okay, they're in different order for me.
Okay. Yeah, the answers might be different order, but so for this, what we're looking for is the standard error. And so standard error is the standard deviation divided by the square root of the sample size. So it tells us right in there that our true standard deviation is equal to 15. So we already know that. The sample size, that's the 2,500 voting adults. How many people were interviewed or questioned for this? So we know that that's our sample size. So then we have to take the square root of the sample size, which square root of 2,500 is 50. So then we take 15 and divide it by 50, and we get our answer of 0.3, which is our standard error.
Okay,
So is there any questions on that?
I hope this isn't on the final because I will never remember that, but okay. All right. How long do you think our research paper is going to have to be for this class?
My guess is 10 pages.
No, it's not
But-
too bad.
I don't know. All right. Does anyone have any questions about finding that standard error?
Hmm.
All right. So we'll go on to question 2. Given the information from question 1, suppose that you found the sample mean of this survey for Biden's feeling thermometer is 55. What is the 95% confidence interval for the mean of Biden's feeling thermometer? And then it gives you your in between this number and that number. And so now we have to remember is for the 95% confidence interval, we have X bar, which is the sample mean, plus or minus 1.96 times the standard error. So we are told right in here that our sample mean or our X bar is equal to 55. So we already got that. We know from question 1 that our sample error is 0.3. So then when we plug these in, so we need to take our sample error of 0.3 and multiply it by 1.96, which that gives us 0.588. So to get our upper boundary of the confidence interval, we do 55 plus 0.588. And to get our lower boundary, we take 55 and we subtract 0.588. And so that gives us our 55.588 and 54.412, which for me was answer A. Are there any questions on how to find the confidence interval?
I think we're definitely going to have to review this for the final because I do not get how you, I mean, maybe it was in our notes, the formula to accomplish this, but I didn't retain any of it.
I want to say this might have been the day that you weren't there.
Yeah, that really screwed me.
So, but yeah, like I went through and I found it in my notes and it was super quick and easy. So
Everything's easy for you in this class. It's not fair. Okay, well, that's awesome that you're a genius. Thank you for helping. All right, on to question 3.
No other questions about finding the confidence interval from anyone else?
Wait, I'm sorry, but what was the answer for number 2?
For number 2, it's in between 54.412 and
Okay.
55.588.
Okay, thank you.
Not a problem. All right, on to question 3. suppose that it is this very same survey of 2,500 adults, which was taken in October of 2020. You asked them if they planned on voting for Trump or Biden. Suppose that you found 1,300 people were voting for Biden and 1,200 were voting for Trump. What is the standard error of this proportion? Round to the nearest fifth decimal. So then it gives you your options for the standard error. So with this, we're dealing with the proportion. Specifically, and this was kind of worded funny. Oh, great. Okay. We got 10 minutes. Hopefully we can get through these last 10 minutes before. Okay. So this is dealing with a proportion, specifically the proportion that is going to be voting for Biden. So that's going to be this 1,300 people. So we have a formula for the standard error of proportion, which is the square root of P, which is your proportion, times the other half of the proportion, divided by the sample size. In our textbook, I think it said the square root of P times 1 minus P divided by the square root of sample size. I found it just easier just to take the square root of the whole thing. So the number of voting for Biden is 1,300, and you divide that by the sample size of 2,500 to get your proportion. So our 1,300 divided by 2,500 equals 0.52. Everyone understand that?
Yes.
Okay.
As good as it's gonna get for me, yeah.
Okay, so then what we're going to have is our 0.52 times 1 minus 0.52, which is going to be 0.48, divided by 2,500. So, and basically, if you just kind of look down here, I have it broken down step by step. So 0.52 times 0.48 comes out to 0.2496. You divide that by 2,500 and you get the 0.00009984. And then when you take the square root of that, you get 0.00999, which is one of the answers.
So the answer for 4 is 0.0099.
The answer
No.
for 3.
Oh, for 3. Okay, yes, sorry, my God.
Yes, so that is the answer. And so, like I said, this is just really easy. You just have this formula and you're just plugging in the numbers and working through it. And so that's how you get the 0.999 or 0.00999. Any questions on finding the standard error of proportion?
No.
Quick question. Yeah, I do. So in the main formula, it's divided by the sample size of n. What did you plug in for n in that formula?
That's this 2,500.
Okay, that's the same. Okay, the 25. Okay, got it. Cool.
Any other questions?
Not at this moment. I'm completely lost. Like, I really need to review this, but I'm trying to follow along as well as I can. So
Yeah, and if you just like, you know, run through these questions again and like do all the math for yourself, that's how I figured it out. And so that just kind of helps you like actually see
remember.
how you're getting it and everything.
Yeah.
So, and you can always hit me up for extra tutoring. So
You know that's gonna happen. So
all right, on to question 4. So given the information from the previous question, what is the 95% confidence interval for the proportion of people voting for Biden? And then it gives us all these numbers. So once again, the confidence interval is X bar or sample mean plus or minus 1.96 times standard error. So we know that our sample mean is that 0.52, which we got it's the proportion. So we got that from 1,300 divided by the sample size to get the 0.52. Then we know our standard error, which is what we found out in the last time, is the 0.00999. So this is when the numbers get all super long, and I really suggest use the full long numbers until the very end. Because sometimes if you do rounding too early, it messes up the math. So the first thing that we need to do is to get our plus or minus, which is the 1.96 times the standard error. And so that is 1.96 times the standard error gives us this 0.019 yada, yada, yada. So we have to get our upper boundary, that's where we have the 0.52, our sample mean, plus that 0.0195 yada, yada, yada. Then our lower boundary is 0.52 minus 0.195 yada, yada, yada. And so that gives us our answer is in between 0.5004157 and 0.0539548. 43, but yeah. So it's same thing as we did in question 2. It's just doing it with a proportion instead of doing it with just regular numbers.
Okay. Not to be like a stinger, but you put upper boundary twice. Did you mean to put
Oh.
lower boundary for the second one?
Yes, thank you.
Okay. Yeah, no, just wanted to know. Okay.
Yep.
Well, awesome.
So that, yep, I did that same mistake right here. Okay, thank you for correcting me on that.
I just wanted to make sure because I'm completely lost, not gonna lie.
Can you send us these notes like on a Word document so
Yeah.
I can remember how to do them?
Yep, not a
Yes,
problem.
please.
Yeah, that would be great. So we could practice.
Just yeah, send in the group chat or the group me, just
Mhm.
send your emails and I'll send that out here tonight to y'all.
Thank
Okay.
you so much.
Not a problem. Everyone good? Any questions on either of these?
No, I think we excelled. I think we're all gonna get A's.
I hope so.
Just a
Yeah,
quick
thank
question.
you for walking us through that.
Yeah, thank you for that. And I'm sorry to ask this. I know it's not relevant to the class, but who here is really good at writing like papers or doing research? I have this incredibly difficult assignment that's stressing me out. It's an annotated bibliography and it's on a